Thank you for attending the first annual SmallSat Education Conference. We're starting the afternoon session now. I'm Kevin Simmons, and I really appreciate you being here. Our focus again is to increase the number of students and educators that are using high-altitude balloons, thin-sats, and CubeSats as a way to prepare them for the STEM workforce. We're very happy that you're here today. In our afternoon session, we'll do a few talks. We'll have an exhibitor break and then a couple more presentations. But first off, this afternoon, I'm very happy to inform you that we're going to have a presenter from Kennedy Space Center who's involved with the University Nanosat program. His name is Mr. Jose Nunez, and I'm very glad that he's here to discuss this kind of interaction between the military, NASA, and university teams. So, Mr. Nunez, come on up.
Let's see, good afternoon. It is after lunch. I'm a little bit jet lagged. But thank you so much for inviting me. I know I was like late in the agenda, and thank God somebody canceled, so I was able to be here. So very exciting stuff that I got to tell you. So my name is Jose Nunez. I have had a relatively new job for the past 2.5 years. My title at NASA, Kennedy Space Center, is the center's University Partnerships and University and SmallSat Partnerships or Capabilities Manager. I'm still trying to figure it out. So the goal is to basically engage university PIs that we have here with our Kennedy Research Center PIs. Easy, right? University PIs with our PIs. We have research areas, in situ resource utilization, excavation, many others. So that's my goal. So I travel to many universities, communicate, bring them in. And in the process, try to engage universities to develop SmallSats, okay? So we give the Florida Space Grant, J-Deep, if any one of you knows him, a list of projects every year for him to then distribute across his Florida Space Grant Consortium distribution. And we have been working with him on with different universities across the state on developing SmallSats. We have University of South Florida, are they here? USF? Maybe they're still at lunch. Florida Atlantic University, are they here? No. UCF? Yes, maybe, all right. So some of the, and Florida Tech, anyone from Florida Tech? Okay, so we've been working with you guys, trying to engage. All right, so let's see. So before I go back, so UNP, and I'll mention what UNP is, but Jesse Olson is the program director. So kind of big deal. And the other name I want to mention is Norm Phelps, who is the director or the project manager for the CSLI, CubeSat Launch Initiative, which I'll mention too. So it is a collaboration between the Air Force, Space Force, the Air Force Research Lab, and us, NASA at Kennedy Space Center. So this program that I'm about to talk to you about got approved a week and a half ago. Okay, so the funding got done, and you are the second conference that I'm speaking to about. First one was yesterday. So UNP. So it is a part of the Air Force Research Lab. They have been in business for about 20 years. They are unique. NASA does not have a program like them, okay? So we're not about to start one. We're trying to leverage their capabilities, their expertise, their experience with ours, okay? So they usually have a competitive cohort program that lasts 2 years. So they take a university under their wings and teaches them how to design, test, operate, launch a SmallSat. How cool is that? okay? So that's what they do. So we're leveraging them. First time that they've ever done it at our request, right, to do a summer program, okay? All right, so a lot of different things have been done. So we're partnering too with different groups, right? It's all about partnering and leveraging each other's strength. So with NASA's Office of STEM Engagement, they're really behind this. I spoke a couple of weeks ago when the project has not even been approved at a conference in Texas Southern University, and the head of the OSTEM office, Mike Kincaid, talked to me afterwards, and it's like, this is awesome. We definitely have to get engaged with this. So they're behind us. They have a program about the minority university research education in Europe. They are also behind us. And one of the emphasis that we're going to try to have, not the whole emphasis, but a part of it, is to engage minority serving institutions and HBCUs, historically black colleges and universities, okay? And you say, well, why? Well, talking to UNP, number one, they have never received a proposal from an HBCU. Never. That's number one. Number two is that when they have received proposals from an MSI, a minority serving institution, their quality perhaps has not been as good, okay? So the question was, and still is, how can we help those institutions get up to par? Fair? All right. So, in CSLI, it's part of it. They're funding part of it, okay? And it is not a guaranteed, by the way, CubeSat launched this initiative. This is NASA's program to help provide a ride to a university's CubeSat, right? So if you propose to it and we think you're good, we'll send you up to space free of charge to you, right? So even though they're part of it, they're a big part of it, it's not a guarantee to be selected as one of their participants. Okay? So the full UNP process, you know, they help you understand design and development, integration and test, environmental test and mission operations. They do that in their full 2-year cohort mission. We're going to try to get all that done in a semester, in the summer semester. So, and this is this coming summer 2023. That's when we're doing this. And here again is, you know, why is it that we're doing this summer series? The next full cycle was in 2020, is in 2024. So it'll be a great time to help university, faculty, and students to prepare, right, a summer program. I've also been, I didn't mention this, I've also been a reviewer for UNP. So if you propose to UNP in 2020 or 2022, I reviewed your proposal. So I was either, so high barrier to entry. Developing a satellite is not easy, as you all know, and they have a very aggressive schedule. So it prepares them for the full cycle. It prepares them for NASA's CSLI, although it's not a guarantee that you will fly. And it's basically trying to improve how you will propose in the future. Program's going to be about. We're going to have a kickoff mission design. Still haven't figured out where yet. It'll be in Albuquerque, where the UNP is, or here, Kennedy. They'll have a kickoff. We'll go through a 2-day nominal course. Then we'll have a series of virtual meetings all about system constant review or systems requirements review. And then the closing and final review, we're thinking either at Albuquerque or perhaps it could be at SmallSat over in Logan, Utah. So that's what you get to learn in this summer series. I think it's great. I think this is a great opportunity. So the secret sauce, right? So we'll be looking for educational impact, the impact and development of your program, minority outreach and support, and NASA DoD relevance. We haven't yet put the details on what specifically, but we will. And so I've heard of the Wolf Pack, which is the first time I've ever heard of Wolf Pack. Awesome, by the way. But you're not so to be able to propose, you have to be a university, right? The PI has to be from a university. So you have to engage with them, number one, whoever you are. Number two, try to engage with a minority serving institution, university, right? Like a PI, let them know, hey, I'm interested, and perhaps can we leverage each other's strength? That would be great. And if you could also do that with a HBCU. So yeah, leveraging, trying to engage proposal for your ability to score high in the office. And we're hoping to do 4 to 8 teams, depending on the funding goes, maybe more. And the goal is to award about $70K per school. So 10 for faculty stipend, 25 for students, travel, overhead. We'll have Space Dynamics, which is UNP's subcontractor to engage with the universities. And we'll have just bare minimum deliverables. The university still owns the products. And the students will have a internship assigned to them. So they will have had a AFRL, Air Force Resource Lab internship. It'll count towards that. So in terms of why participate, summer is a good time. Faculty is no longer required to deal with other funding sources because we're giving them what they need. We're hoping to have a faculties and 4 to 5 students to be part of that group. So that's the intent. And there will be summer interns of the Air Force Research Lab. It allows the professors to form a team without much existing support. So it's not going to be a drain on the universities. And then we have travel allotted to, so they could travel to different events. So it's a win-win scenario, I think. I wish I would be younger so I could do that. So inaugural program coming up, summer 2023. UNP is going to provide their guide, which is an awesome version of their program. They have design course curriculum. They got over 30 presentations on recordings on design. They'll have engineer review support, contract support, student intern housing, event planning. All of that's going to be provided. We're providing money for them to add more schools. We're also going to be part of the review team and support, and we're trying to figure out what kind of conferences we're going to have as well, and in terms of hosting the events. So key January 5th. In fact, this is so the last charts yesterday, and I forgot to put down the website in which the solicitation is going to be available, and it's simply universitynanosat.org, which is UNP's website. So my apologies for not putting that in. So once the request for proposal or RFP is released, January 5th, you'll have about a month to get your team together, put the proposal together, going through reviewing, and we'll have a kickoff mid to late May, and then follow up by all the other milestones. And then we're hoping to do the final event either at the SmallSat or subsequently thereof. So any other institutions that they'll be willing to partner with them. Can they bring smaller, school type, middle, high school? Yes, but it has to go through the university. So if the university utilizes you as their partner or partners, We don't care. Okay? So you can. You can. Right there, looking at me. You can. So, otherwise, catch me during break, and I'll be able to talk to you anything you want. We good? All right. I think that was it.
So our next speaker, is going to be John Moore, and our speakers are John Moore and Max Freidman. I first met John Moore as he was an Albert Einstein Distinguished Educator Fellow assigned to the Geosciences Directorate at the National Science Foundation. John has a long career of using actual satellite data in the classroom with his students, and he's currently the director of the Institute for Earth Observations and runs the Palmyra Cove Nature Center up in New Jersey. Max was a former student and now a robotics engineering student at Worcester Polytechnic Institute. It's my privilege, honor to introduce John and Max.
Well, good afternoon, everybody. So what Kevin just said will start us off. I will say this, our A-CubeSat project, which we're going to explain, is a little different than maybe some of the things we've heard this morning. The objective to design this was to go to pre-college students across America, really to broaden participation. So we know there may be thousands of you, young people across the country, that are doing the wonderful things we're hearing today, but I'm sure I'm preaching to the choir. There are 10,000s of students in this country alone that will never have heard the word CubeSat. Kevin and I have known each other for a long time. We started out really to reform STEM education. So I'm from New Jersey. I say what I think, and I've said this publicly before, and I'm old enough that I don't care what you think about me anyway. But you know about FIRST Robotics. There were thousands, hundreds of thousands of dollars spent in FIRST Robotics. The schools adopted that right away. And so our talk was, why are you building toy cars when you can be building space-ready satellites? So that's our initiative. So you want to, this one here, right? Okay. Oh, we're on there. So here it is, A cube, A to the third power really came, and this titled slide, you can read it. But it started in really remote sensing. And after all the words and books and papers that you could possibly write to get it the simplest form as it can, it's about acquiring data or imagery to analyze that data and then have application for it. And I'm just looking over, seeing my potentially new friend from Pocket Lab. So I am a geoscientist. I'm not an aerospace engineer at all. So that's where I'm coming from. This one goes, right? Okay. Okay, so just a little background into the some of the things that we've worked with in the geosciences, which came to the direction for what Max is going to tell you. He developed all this, but it's to look at different layers going up through the atmosphere from the ground up into space. So, you know, I'm old enough that we looked at, you know, looking at the NASA Earth satellites and looked at how to get that imagery into the classroom. I am old enough that I was teaching this stuff before the internet or even the personal computer in the classroom. So this is where we started and where we are now, looking at and creating layers. So we work with a program, Globe Mission Earth, which is a NASA-funded CAN project, excuse me. And so this is a globe observer. So the reason I have this slide up is to show the geoscience connections. And all these are student projects where they can observe the data on the ground with NASA or NOAA Earth observing satellites. So like clouds is Terra, Mosquito is GPM, trees are ISAT-2, which is a different. Okay, so I'm going to turn it over to publicly. I brought ideas. I found Max at the technical high school that I taught at for 20 years. He was a pre-engineering student, but his teacher came out of Lockheed Martin building CubeSats. I found another human being in my neighborhood that knew what the word even was. And I said, this is what I'm looking to do. Do you know any students that can handle it? And now I'll introduce you to Max.
Hi, everyone. I might want to move that down a little bit because I'm a little short. I think that what's important about the ACubeSat is we're trying to integrate how that would look in the classroom. I think every classroom, every kid interested in science should be looking towards CubeSat and CubeSatellite technology for how they can get introduced or even progress their skills in STEM. And I think that every school and every student who's interested in that has the ability to eventually build something that could go into space. It's something that students are inherently capable of learning from their own mistakes and moving towards that. But a lot of teachers, I feel, are afraid of taking that step. They need more guidance in how that lesson's going to turn out. So I think that that's kind of where ACubeSat comes in. It acts as an emulator so that students can learn how to acquire data, analyze that data, and apply it to whatever they're trying to learn. It comes in a kit where we can have 2 cameras on the bottom, environmental sensor on the front, runs with a Raspberry Pi, which students are often very familiar with if they're interested in electronics at all. And newly, it also has solar panels on the top, so that way you can actually charge the battery and learn how light might affect the charging rate. All of these things kind of coming together so that way you have a robust system for learning about electronics and applying that towards the idea of satellites. And this was kind of like the top middle picture. You kind of see how it's all a bunch of wires inside that students have to learn how to connect. On the left-hand side, you can see, actually, it's the right-hand side for you. The right-hand side, and we're working on adding more graphs to our version 1 ground station. So you stream, and groups like the U.S. Naval Academy and the students that actually worked on this on the right-hand, or left-hand side for you. The left-hand side where you can see how students kind of came together to actually build this. This was all student-built. I was in high school when I built this. I'm now a sophomore in college. And that's kind of how our version 1 comes into play. Here's some more images to kind of show how how we worked with the U.S. Naval Academy, with Jack Woods at the Naval Academy, who was intern that summer, and Jin Kang, who spoke earlier.
So the person that's not here is Saram Malongo. So he came in when he was a sophomore, found me wanting to do research, and picked right in. So he's really exceptionally gifted in, he likes AI, but in programming. So Max built the CubeSat, and it was attached to a drone. That's how we flew it. And they were doing the high fives. And then my job as an educator is to step in and ruin the party by saying, yeah, but all these images that you caught for me, you have to download off the CubeSats, and in real life, you can't bring a satellite down to get the information. So can you figure out a way to do a ground station when we can download that? Saram stepped up to the challenge. He did it, started from the beginning. And also he submitted that there's a national congressional app challenge hosted by every congressional district in the United States. In New Jersey, which is where we live. Saram won last year. So we want to highlight him. And up in the right corner, that's our Congressman Kim came out to our center and awarded Saram that award.
And that kind of brings us on to version 2. Version 1 is absolutely great, and we intend, once some Raspberry Pi shortage issues are solved, to keep rolling out version 1 because it's a great introduction to Cube satellites. It gives you in the fact that it's controlled by a Wi-Fi connection. So you put it up on a drone, maybe a tethered balloon, but it doesn't give you the ability to start developing on your own or to go that long distance, say, for example, with a high altitude balloon. And that's where version 2 comes in. This is a printed board with electronics components on top of it that gives us more analytic data about the actual status of the CubeSat. Things like gyroscopic rotation, the acceleration, the magnetic direction, its GPS location. All these serve as avionics data, so that way students can then build their own payloads. In version 1, can you show the bottom of it real quick? You see how it has the 2 cameras. Those cameras are great, But what we wanted to do was give the option for students to develop their own payload, whether that be cameras or a scientific experiment. And that's what version 2 allows us to do. This is one of the frames that we're looking at using for version 2. Only about half of the space would be used by our electronics, allowing the other half to be used by any type of student payload. It also has a radio transmitter, so you can go longer distances and possibly even collect data throughout the entire length of a high altitude balloon. On screen, you'll actually see all the features, and we've highlighted some of the bigger ones that this version 2 board allows us to do. We're planning to do a high altitude balloon launch, probably not next weekend, but the weekend after. We're trying to get our hands on some helium, and there's a shortage right now. But barring any issues, we will soon be doing a high altitude balloon launch to fully test the range of this transmitter, which is rated at least 12 kilometers. The other project that we're working on is our QFH antenna. For anyone who's familiar with NOAA satellites provide direct readout images of certain weather conditions and certain layers of the atmosphere. Using a QFH antenna, a quadrifilar helicoidal antenna, if I believe, you can actually receive those images just as their own spiral-looking antenna and be able to pick up that satellite directly when you want to.
Okay, so in closing, I'd like to thank a couple people you see up on the screen. First, Dr. King, who you all met this morning, been an invaluable partner. I met him about 12 years ago, and he has a true heart for STEM. Professor Twiggs helped us vet this because I didn't want to make a little toy. I wanted to make something that was authentic. And Professor Jabot is from SUNY Fredonia, and he helps us with the educational leadership and outreach. I'm going to end my quote. I write a little article for the Satellite Educators Association. Somebody picked this up. Remember, you can teach anything with satellites. And the last thing I want to do is that this is very inexpensive, because I've heard for too many years from teachers or schools, it's too expensive to be involved. This is very affordable. And so as a geoscientist, out pictures. So one thing I don't like about version 2, it doesn't have cameras, but we're going to figure that out. So Kevin Simmons announcing for next year, we're going to have a subcommittee about putting cameras, and the title is going to be No Camera Left Behind. Every satellite should have a camera on it, kids and adults. Okay, thanks a lot for everything. We appreciate being here.
He just loves to make my job hard.
So our next presentation is actually going to come from Nebraska. I have to tell you a story. Shauna and I were with some of our CubeSat kids at the Michigan Space Conference in 2019. This man emails me. His name is John McClure, and he said, I'm from Nebraska. Your students really impressed me. I want to build something for my grandson, my grandchildren in Nebraska. And Nebraska had never launched a CubeSat, and we got really excited about working with this. John McClure had worked with, I believe, GM and been a part of OnStar. And anyway, John McClure, he's since passed away. But the thing that he started in Nebraska that the Wolfpack kids were a part of, I'm really proud of them today. And so that's why they're one of the few groups that we wanted to present, even though they couldn't be here. So, of course, as you heard Mr. Nunez says, it's very important sometimes to have the right university to work with. And so what we have today is members of the Big Red Sat team, Miss Karen Stelling and Vince Orsai, one of the students, and they are our next presentation. So I'm going to ask Miss Stelling to come up and say a few words and then introduce the team that hopefully we'll be able to show you on the screen that'll be presenting. So.
Hey, Kevin. Kevin, can you hear me?
Barely.
Okay, we cannot share our slides right now because it says that the host disabled screen sharing. Is there a way for you to enable screen sharing on the Zoom?
Mr. Albrighton can do it since I made him the host. I'm not I don't have Zoom on right now.
Okay, thank you.
Yeah, that's John.
Oh, fine. Okay, so I have your slides, but I guess we'll wait for your slides to come up.
Okay.
But you're welcome to go ahead.
Well, we'll go ahead and start, and then we'll just, we'll flip it over to them, so.
Okay.
Good afternoon, everyone. I want to start off by saying it's a privilege to be here representing my team. We're very excited to show you guys what we've been working on in developing the very first satellite from the state of Nebraska. Yeah, my name is Vince Horsey. I'm a freshman at the University of Nebraska. I'm joined here by Miss Karen Stelling, the director and advisor for the Big Red Sat satellite team, as well as the aerospace team at the university. I will now pass it to Karen to introduce the team.
Hi, thank you. Actually, it's interesting. I was going to tell a little bit about the story about John. So after he met Kevin, he went to the University of Nebraska and said, hey, we want you guys to sponsor the middle school, high school team. And the dean agreed to do this, but I am the advisor for the aerospace club. We have 6 different teams. So we did Lunabotics in here this past fall. And they said, hey, Karen, we want you to start this. And I'm like, yeah, not by myself. And so one of our teams, the Aerospace Experimental Payloads, AXP team, they have done RockSat and USIP and other programs, and they wanted to do a CubeSat but couldn't afford it. And so here we had this opportunity because John was going to help raise the funds. And so what we are is we're a team. We were fortunate. We have 2 leaders. You're going to hear from John. Joel be in the room, who were sophomores, undergraduate sophomores, who were the leads for the AXP team. So here you can see pictures. We got our slides up, great. And so they said, yes, we'll take this on. Then we actually went to the science teachers across Nebraska for middle school and high school and said, please share this with your students and invite them to apply. And so what we have is we have an undergraduate team. They're the ones who lead the technology, not me, who are mentoring a middle school, high school team. Most of our students are from Omaha and Lincoln, not from the same high schools. And then we also are fortunate because several of our engineering school graduates are mentors to our team, and they work, at NASA or in the satellite industry. And so that's how our team was formed. And I'm going to turn it over to John. He'll give an overview, and the rest of the presentation will be from Nebraska.
Thanks, Karen. So this presentation is just going to cover what our team is, our mission, what progress we've made on our CubeSat project so far, our plan for the road ahead, and then the impact we hope this will have on our BRS students in Nebraska. So now I'm going to turn it over to Elsa to talk about our mission.
Hello, I'm Elsa. I'm a sophomore in high school. And so our overall team mission, we want to build the future of aerospace and STEM in the industry in Nebraska. For this specific mission, which we're calling Big Red Sat 1, we want to develop Nebraska's first ever orbital payload and CubeSat. For that CubeSat, our mission objective will be to functionally test and compare the industry standard of gallium arsenide cells with the new and upcoming perovskite solar cells in efficiency and lifetime in a space environment. I'll pass it off to Nick to talk about our progress so far.
Thank you. So we made some progress over this last year. We've learned useful programs and processes to help develop our projects. We've proposed and selected for a grant. We've launched a high-altitude balloon to apply ideas and gather our data. We've also progressed in designs and prototyping and built collaborations to help us. We've also been testing and refining designs with our engineering model, and we've been doing a lot of troubleshooting on that. Here's Brett with the timeline.
Okay, in August of 2020, we formed our team, and it took us a little while, and we ended up selecting perovskites for our project. We were selected by NASA, and our first HAB launch was in spring of 2021. Fast forward about a year, in June of 2022, we had our HAB perovskite test, and after that, we received our engineering model, and then we did payload testing and stuff. In our future, we are going to do engineering model flight testing and flight model testing once we receive it in December of 2022. We will, in May of 2023, we are going to hand the CubeSat off, and we're going to launch it in like late 2023. After launch, we are going to like analyze the data that we collected from like everything that happened. Yeah, and I'm going to hand it off to Robert for our payload.
Hello. Our payload that we'll be launching on this CubeSat satellite is testing perovskite solar cells. We chose perovskite solar cells as our test because they have the potential to compete with industry standard solar cells such as 3,5 gallium arsenide solar cells and silicon solar cells. Some ways that they are is that they're a lot thinner than them and lighter weight, making them easier to send on a rocket. They have similar lab efficiencies to silicon solar cells, giving them the chance to be feasible for the efficiency and powering things. And they have a high specific power, which is basically compared to their rate ratio to power ratio, they generate a whole lot of power for a little amount of weight. Of course, perovskites, they have their issues, such as they aren't the best in moisture and oxygen. And frankly, that's caused us to have to remodel things on our CubeSat. And as you can see on the picture on the right, we have a little model of what we've done. The perovskite solar cells are in the middle, and they're basically in a metal box that's held together with a gasket and epoxy. It's airtight so that moisture and oxygen cannot get into the perovskites, so that we don't have any degrading here on Earth before they get launched. Also, with this payload, we've collaborated with Rhodes College, which is one of the 3 teams that also got selected for launching a perovskite CubeSat payload. We have been working with the University of Oklahoma, who is providing us with our solar cells. And Mr. Simmons and Ms. Jerkins have helped us in our proposal and getting this program started. Next up, Brooks will talk about some of our challenges along with John.
So we've had a lot of challenges with our payload. So one of those includes limitations with space. We had very little space to work with, and we had to 3D print our payload to the exact inch. Along with that, we've had problems with the sensitivity of perovskites, as Robert said. They're sensitive to moisture, oxygen, and they have problems with electrical charge stations. And they're very small and fragile, so they're less than a millimeter. Most of that is glass. As well as that, we've had problems sourcing our components and materials. Thanks to University of Oklahoma for the solar cells, that helped a lot, and we had problems finding the fast bus. And the supply chain caused a lot of problems as well. There's overall, COVID really ravaged the supply chains. Next is John.
So one of the other hard things about this project is that not only are we trying to build our first ever CubeSat, but we're also trying to build this team from the ground up at the same time. So we've had to learn things like team building, and for the undergraduates, how to transfer knowledge to our middle school and high school team. We've also had to work with issues around coordination. The university students and our undergrads are based out of the University of Nebraska-Lincoln, but we have kids everywhere from Omaha to Lincoln and in between. That means that although we try to meet in person as much as possible, which is kind of hard this fall with all the home football games, most of our meetings that are not in person are just on Discord. However, despite all the challenges with coordination and team building and all the technical challenges that we face, this has been a really rewarding experience overall. Now I'm going to hand it off to Elsa to talk about the impact that this experience has had on our BRS members.
We've gathered a lot of quotes from our team members, our middle school and high school team members. You can read them on our slide up here. So a lot of what people said is that it helps them get a hands-on experience that they would not have gotten in high school or middle school or maybe even college. We get to interact with aerospace professionals as well as undergrad students, and it gets a lot more opportunities. It helps people get known in the industry. A lot of people said it was a great learning opportunity. and it gives them a chance to kind of figure out what they want to do, whether that be college or as a career, and everything like that. It's also helped with public speaking skills, as like in this, we have a lot of our middle school and high school team members doing presentations that you wouldn't have gotten to do in high school. And you get to build knowledge in real world situations that you just really wouldn't get to do otherwise. All right, that's pretty much all we have. So we can take questions if anyone has any.
All right, good afternoon, everyone. Before we go into the next few presentations, we just had some additional announcements. For anyone that entered into the 3D printing design competition, we will be announcing the winners of the scholarship tomorrow during one of the sessions. Additionally, anyone who entered into the raffle for the 3D printer out there, we'll be doing that at the end of today's session. So please stay tuned, and we'll be doing that here in just a couple hours. And I'd like to also pass it over to Kevin to announce the winner of the art contest.
Thank you. So to just show you how awesome aerospace is in general, Sean and I had a young lady we taught in middle school who's now in high school, fantastic artist, writer. For a long time, she wasn't involved at all with aerospace. In the last few years, not only has she edited a book, illustrated a book, which is sold on Amazon for young kids to learn about the ISS and the Falcon 9 first stage landing. She writes blogs for our web. She is the creative force behind our art contest. I asked her, would she help us make an art contest and help me find the judges? And I thought it only fair that she couldn't be here today, but she recorded a video to announce the winners of the art competition. So I want all of you students to know that no matter what your passion is, there's room for you in the world of aerospace. So let me cue up this short video. Her name, by the way, is Amanda Broaden. You'll probably see her a lot down the road. She's going to be, I think, a really good human. When she hits the workforce, you should probably hire her. So.
Welcome to the inaugural SmallSat Education Conference. Art can be seen throughout planets near and far, between solar systems and black holes, and even in the construction of new and futuristic rockets. With new discussions orbiting around space colonization and what life in space may look like, the idea of moving to a different planet may not sound so distant in the coming years. Who better to predict what our lives may look like in a colonial spatial setting than the next generation of astronomical artists? Our inaugural prompt for this year was creating a promising future in space. Students were instructed to create a piece depicting a daily scenery of colonized space, possibly including methods of transportation, food harvesting, and other ways of adapting to this new environment. Entries were judged between junior and senior groups, ranging from 6th to 8th and 9th to 12th grades, respectively, and followed the rubric guidelines of originality and creativity of design, adherence to the provided theme, usage of medium to complement design, and a short description. For our inaugural year, we were speechless in seeing some of the impressive pieces that certainly made us question what our future in space may look like. And now, for the moment you've all been waiting for, here are the winners of the first annual SmallSat Education Conference Visual Art Contest. For the junior group, in 3rd place, we have Sean Bartello. In 2nd place, Rafe Johnson. And in 1st place, we have Finley Smith. Finley's entry is composed of several components of futuristic space living, from making hardware repairs to walking your dog, who also wears a spacesuit. We enjoy Finley's comprehensive description of how several ordinary tasks in Earth may look different in space. For the senior group, in 3rd place, we have Zania Walker. In 2nd place, Jaira Sanchez. And in 1st place, we have Kiani Young. Kiani submitted an impressive piece depicting a character writing of her futuristic life in space, from how she obtains water previously used on Earth to her diverged feelings about living alone on a foreign planet. We enjoyed her use of a digital medium in portraying a thoughtful story. We thank our young artists for submitting their stunning works of art and hope to see more entries next year at the second annual SmallSat Education Conference. Thank you again to our sponsors, AIAA, Cape Canaveral, and LAGU for making this competition possible. Thank you, and let's go to space.
Thank you. Amanda actually created our logo, so when you see the diamond logo for our conference, she actually created that as well. All right, at this time, we have one more break scheduled, and then we have really 3 impressive presentations left for our first day. When you're released, please meet with the exhibitors, talk to the students, and network. When you come back from break at 3 o'clock, we'll have the Florida Institute of Technology. We'll have students for the exploration and development of space. And then we'll have One Voice for Change with a really nice announcement that we're making. Thank you again, and we'll see you at 3 o'clock right here. Thank you.